Okay, today we are going to do sketching. So these aren't going to be super accurate, but sketches of some polynomial functions and what it means to have end behavior. So over here to the side, you'll see I have a little chart here of all the possible end behaviors. So to talk about what I mean there, I'm going to just use this blank space right here. Okay, so this is based on a leading coefficient. Of your polynomial. And so I'm going to talk about what I mean by that. I'm just going to start with the most basic case. Let's say we had the line y equals 2x plus 3. Okay, so I'm just going to make a little tiny xy axis and sketch a graph of that line. So we'd start at 3, go up 2 over 1, so just a little sketch would look something like this. This is a positive leading coefficient because the coefficient of x is 2, and this is what we call an odd power because x is to the first power. Now, the end behavior is how does the graph point to the far left and how does the graph point to the far right. So you guys can see at the end of the graph I'm pointing down, and as I go over I'm pointing up. So any odd power of x is the highest power, and any positive leading coefficient is going to have that same end behavior. Now, let's just change something up. Let's say I had negative 2x plus 3. So just do a little sketch here as well. And so we'd start at 3, I'm just kind of ballparking, and we'd go down 2 over 1, down 2 over 1. So slope of a negative, or line with a negative slope is going to go down like that. This is negative for your leading coefficient, so negative 2. This is still an odd degree polynomial. X to the first is the highest power. Negative leading coefficient with an odd is going to go up at the beginning of the graph and down at the end of the graph. Okay, and now I'm just going to do the most basic even function. So if we had, let's just say y equals x squared, quadratic parabola, it's going to go through the origin, and you guys know I'm just going to kind of sketch to give you an idea. Now, the leading coefficient here would just be a positive 1, so this is positive. And my highest power of x is 2, so this is a positive and even. Now, anytime you have an even graph, the end behavior, the ends will both point the same direction. If it's positive, both ends will point up. And then you'll see here, when I write down my negative example, if I did negative x squared, you guys know this would be at the origin, and we're going to turn down because of the negative. So my leading coefficient here would be negative 1. So this is negative. The highest power of x is x squared, so this is an even degree polynomial here. And you guys can see that if I am negative with an even as my highest power of x, the end behavior is to point down and down. So these are the most basic examples, and you guys can use this chart as a reference. Okay, so we're going to start with example 1. You're just sketching these. Pause this at any time if I'm kind of moving too fast. We're going to write down the zeros, of the function. Okay, so let's see. Here we would have 6, here we would add 1 and divide by 2, so a half, and here we would have negative 2. Those are going to be my zeros of my function, so these are going to be important to identify on the x-axis. Okay, the other thing you have to determine is what is your leading coefficient. Okay, so I'm not asking you to multiply this out, but think about it. If I did multiply these all out, I would have the first term in each of these, and I would multiply them. Make sure they're all in standard form. This would be x times 2x times another x, so the leading coefficient would be 2x to the third here. Okay, this is positive, and then the exponent is odd. So positive odd is going to point down at the beginning and up at the end for its end behavior. So we're going to go through and work through these zeros to do a sketch here. So let's plot these zeros. -2, a half, just kind of ballpark like right in there between 0 and 1, and then 6. Okay, now here's how I do these. I know the end behavior is going to point up at the right of the graph and down at the beginning of the graph. And any of these zeros, we're just going to go right through the x-axis. I know I have to come back down. This is just a sketch, and I have to go through this point. And then I know I have to come back up to go through this 0. So that would be a good sketch of that first polynomial. All right, let's move to this one. My leading coefficient here, in standard form, just think about what would you get as the highest power of x if you multiplied it out. For this question, -x times 4x would be -4x squared. So this is going to be an even exponent here as your degree and a negative leading coefficient. So this should point down, down. This is just a sketch. Now, if I set this equal to 0, I would have -x, we would add 5, and then we would end up dividing by -1. So this is actually a little bit weird, but the 0 there would be -5. If I set this equal to 0, we would subtract 3, divide by 4, so that's 3/4. As a decimal, that's about -0.75. So we're just going to kind of ballpark those two on the graph. So here's -5. -0.75, maybe about right in there. Okay, now I know my end behavior is down, down, so I know this is going to go down, this is going to go down, and we're just going to go through the x-axis. We have to come back down to go through the other 0. We're just doing a sketch. This is not perfect. Slide this up. Okay, now leading coefficient here be 2x times 2x, which is going to be 4x squared. So this is positive, this is even. We should point up and up. And we're just going to determine the zeros here real quick. Here I would add 3, divide by 2. Here I would subtract 9, divide by 2. A little bit better of a ballpark here. This is 1.5 as a decimal, -4.5 as a decimal, if that helps. So I'm going to estimate. Here's about 1.5. Here's about -4.5. I know my end behavior here should be up, up. So on either end of this, I'm going to go up. And we're just going to come right through the x-axis. We know we have to come back up to get there. And this is just a sketch. The last one in this example is going to have a leading coefficient. You have x times -2x times x, which would be -2x to the third. So this is negative and an odd degree. So this is going to point up at the beginning and down at the end. And we'll just have to identify our zeros right here. 0. Right here we'd subtract 5, but then divide by -2. So that negatives are going to cancel. That'll be positive 2.5 or positive 5 over 2. And this will be 4. So I'm going to just put those on the x-axis. 0, 4. 2.5 is going to come right between the 2 and the 3. So I know I'm going to point up at the beginning and I'm going to point down at the end, and you're just going to take and wave through here. These are just a sketch, just an estimate. If you do want to look at any of these graphs a little bit more accurately, I would recommend the website Desmos.com. Type in the equations and get a good feel. You can also type these on your graphing calculator. You're probably going to have to change the window to really be able to view the graph, but we're just doing a sketch. Okay, now something that does affect how you would graph and your end behavior is if you have a multiplicity, which we haven't seen on any of the questions yet, but I'm going to talk about it here real quick. If you have an even multiplicity, what's going to happen is it's going to create what I call a bounce, and that means at that 0, you're not actually going to go through the x-axis, you're going to bounce back the direction that you came. So if you guys could look just for a second as you're writing this down, or pause or whatever, right here in example 2, I have two situations where there's a multiplicity just to kind of illustrate what a bounce looks like to you. So there's a 0 right here at 0 on this graph, and you can see I'm coming down, 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 but I don't actually go through the x-axis. This bounces back up and then eventually comes back down. This is also a situation where you would have an even multiplicity here. You're going through, you get to this 0, you don't go through the x-axis, you bounce back up. We're going to graph these below example 2. An odd multiplicity. So all of the ones on the front were an odd multiplicity because we just had 1 as an exponent outside of any of those parentheses. So that goes through the x-axis. If you would have something to the 3rd power, something to the 5th power as you're looking at the factored form, you do go ahead and go through the x-axis. Now, before I have you guys graph, we're just going to talk about a degree really quick. Okay, so this is determine the lowest possible degree. We have talked about this before a little bit about looking at the zeros on the x-axis. Now, you should be able to draw any horizontal line that would go through all the parts of the graph. It doesn't have to be the x-axis. Now, in this particular situation, all the little loops of the graph do go through the x-axis. We have 1, 2, 3 zeros. So this is at least a 3rd degree polynomial. Okay, now here I'm going to go and I'm going to draw a horizontal line up here. And so all the different waves of the graph, even if they don't all touch the x-axis, this can create a higher degree. So I'm going to look at this. If you can touch all the different parts of the graph, that'll help you determine the lowest degree. So this graph actually only goes through the x-axis 3 times. But you guys can see the end behavior is down, down, and so this actually has to be an even degree. And if you slide this up just a little bit, we see we go through that horizontal line 4 times, so this is at least a 4th degree polynomial. 3 would not have made sense here because the end behavior is down, down. It has to be an even function. This is going to be a little similar. I'm going to come up here. This is up, up, so this has to be an even degree. And you guys can see this horizontal line, I go through 1, 2, 3, 4 points, but actually on the graph, I only went through 3. This is just going to indicate that we have either a multiplicity or maybe an imaginary 0, but the lowest degree here would also be a 4th degree polynomial. Okay, now the questions at the bottom are going to deal with you trying to graph a multiplicity. I am going to pause this video real quick because I'm going to run out of time and write the factored form of each one of these. Okay, these are written in standard form, so it's actually very easy to see the leading coefficient as you start the problem. This one is x to the 5th, so this is positive and odd, so I know this is going to go down at the beginning and up at the end. We do need to put it in factored form so you can see where it's going to cross the x-axis. And so this is 0 with multiplicity 3. This is going to be 3 with multiplicity 2. Anytime you have an even multiplicity, which I do here, that's going to create a bounce. So what I'm going to just recommend is when I put these zeros here, 0 has got an odd multiplicity, so no bounce. 3 does. Just put a little circle around anything that's got an even multiplicity so you guys remember, don't go through the x-axis at that point. Okay, so I'm going down at the beginning of the graph, up at the end of the graph. Now, I have an odd multiplicity at 0, so we're going to go ahead and go through. I have to come back down because we have to touch 3 here on the x-axis, but then you guys are going to see here I have a multiplicity of 2, creates a bounce. I don't go through the x-axis, so we're going to come back up. The graph right next to this, sorry I'm going kind of fast, leading coefficient is negative, x to the 4th. So this is negative and this is even, so I should point down, down. I factored this. I pulled out a negative x squared. Because of that, I get a difference of squares here. This makes it easier to see your zeros. Now, I have an even multiplicity here. This will just be 4. This will just be negative 4. So 0, I'm going to put a little circle around it, negative 4 and 4. And then I need to go down both at the beginning of the end for a negative even. Okay, this is an odd multiplicity, so go right through. You're going to come back down because you have to touch 0. Even multiplicity is going to bounce this back up. It's not going to go through the x-axis, and it's going to come back down. And we're just doing a sketch. This doesn't have to be perfect. Okay, leading coefficient here is going to be x to the 5th, sketch of the graph, and I'm going to run out